Hello, my name is Pascal, and I'm this year's team captain for UAV Concordia for the competition. My tasks included getting familiar with our GCS software, planning flight tests, as well as running flight simulations. I was also in charge of making sure that our system can communicate with the competition's interop server, get its mission, and send its telemetry data throughout its flight.
My name is Pierre-Lucas Aubin-Fournier. I will be the safety pilot for UAV Concordia at AUVSI 2022. I piloted UAV Concordia's competition drone in many of our recent flight tests, helping fulfill the flight readiness requirements. I am also the holder of a Canadian Basic RPAS pilot license, and I have completed the FAA's trust test to be allowed to fly recreational drones in the US.
Hello everyone, my name is Nicolas Fortin. I am a second year undergraduate student in electrical engineering at Concordia University. I am involved in the mechanical and electrical design teams of UAV Concordia. For this year project, I was involved with the design of two PCB. One is a power distribution PCB that connects the batteries to the motors, and the second one is a signal and small voltage distribution PCB. I was also involved with the mechanical design of the brackets that hold these PCBs. For this year competition at AUVSI in June, I will be responsible of the power system of the drone as well as the power system of the base station. Thank you.
My name is Bao T. Tai. I'm a member of UAV Concordia who will be attending AUSI SUAS competition in 2022. My role within the team is a safety observer and a mechanical specialist member. I am a mechanical engineering student in Concordia, and I have been with UAV for 4 years in multiple different positions.
The drone we are flying at the competition is a hexacopter. It will use a Pixoc flight controller flashed with ArduPilot software. It also has fixed landing gear. Communication between the UAV and the ground control station is done through RFD900X telemetry modules. The drone can also be controlled using a Taranis X9D controller. Our drone will use a LiPo battery as its power source. Due to the limited resources and team members during the last 2 years, we only plan on attempting the autonomous flight portion of the competition. We have high confidence in successfully completing the competition's autonomous flight task, as we have performed many autonomous flights through simulations as well as live flight tests, where the need for manual takeover from the pilot was close to none. Our script will utilize MAV proxy, PyMavLink, and DroneKit to create the autonomous mission and send it to our drone. We will also be using the interop clients libraries provided by the competition to upload telemetry and create our mission. Our team has conducted many simulated and real flight tests. Through these mission tests, we are confident in respecting setup, mission, and teardown times from the timeline criterion of the grading scheme. We are confident in our scripts to prepare our drone for an autonomous mission. We are confident in our teamwork and communication skills as each of our members on the flight line has been assigned and practiced specific roles. In summary, we think we will get our points from the timeline, autonomous flight, and operational excellence portions of the grading scheme, which has a sum of 30%.